This conference will now be recorded.
Yes, good morning everyone. Online whether it's audible. So can someone respond through online student whether it's audible?
Yes, sir, it is audible.
Okay, thank you. So today here we are for PD demo, right? So what is our agenda of discussion today, right? So we are discussing about first thing is we are discussing about course details, right? First I'll start with course details. Next is next I'll discuss about what is physical design. So first I'll start with course details because some are busy. Some who already know what is physical design, right? Let them first attend course details. Next, I'll explain what is our PD course content. Next, fourth thing is right your queries. If you have anything, right, you can ask queries now also. If you have any queries, you can ask me. So this is what I'm going to discuss today in our entire discussion. Right. First, I'll start with course details. See, course physical design course. Yes, is anything asking to me? Hello, online students. Anything you are asking to me? Online participants. Okay. So when I talk about this PD course, right? So this is for almost done for 6 months. A total duration of course is 6 months. So and again we split this course into two parts. One is part one is basics and part two is advanced physical design. Split into two parts. Right. So content of advanced physical design. What is content? I'll discuss here. PD course content. After discussing what is physical design, right? After that, I'll discuss what is course content, content of advanced. But I'll tell what is content of basics. So in PD basics, so I'll also discuss how many months, right? So this is for 2 months, and this is for 4 months. Right? This is what the split up is, and basics. If I talk right, so we are going to cover digital, Unix basics, Unix commands, like what are the operating system we are using, what are the tools installed that is installed in Unix environment. So Unix commands like how to create a folder, how to copy a file, what are the grep commands, what are op commands, what are search and replace commands. Right. Next is GVM. Next is TCL. All EDA tools can understand only TCL, tool command language. So we train students on TCL, CMOS basics. In CMOS basics, we discuss about what is semiconductor, what is MOSFET, what is CMOS, what are different CMOS circuits, what is layout, what is fabrication strategy, what are lower lower technology issues, why we go for FinFETs, why you're not using MOSFETs. So those things are discussed in CMOS basics and some concepts of PD basics. Like what are terminologies, right? What do you mean by core area? What do you mean by die area? What are ports? What are parts? Some terminologies are discussed in PD basics. So these things are discussed in basics of physical design, which is going to start after this means day after tomorrow or tomorrow, right, for this batch. So it starts from digital and it will end with PD basics. And each may take 1 week. Digital may take 1 week, Unix may take 2 to 3 days, GV may take 2 to 3 days, TCL may take 1.5 week, CMOS may take again 1 week, PD basics may take 1 week. Total duration is 2 months. And only digital and CMOS, digital and CMOS is like presentation type. Unix, GVM and TCL is hands-on session, practical session it is. It's not a discussion. So mentor will work, along with the mentor you will also work in your laptop. You should bring your laptop, right? So this about your basics. Next is our advanced session. So advanced course content I told you I'll discuss later, right? So we are going to cover advanced physical design completely. So here, how it is advanced is split I'll discuss. See, this basics is done on weekdays, Monday to Saturday, every day 3 hour session. Mentor will take 3 hour session. After that, they'll give assignments. So assignments, they will sometimes assignments they discuss in class itself, which is very difficult. Means morning you will be having sessions, afternoon they'll discuss assignments for digital and all. For TCL and all, mentor will give you assignment, you should do it. You can do anywhere. You can do it in here or you can do it in home also. So basics will happen on weekdays. It's Monday to Saturday. And if anyone can attend on weekdays, for example, there will be some working professionals who cannot attend on weekdays, they can request for the institute for the classes on weekends, only on Saturday and Sunday. Only this is for only the candidates who cannot attend on weekdays for basics. So this can be on Saturday and Sunday. So institute will make arrangement for that, because generally we have less candidates who are opting for weekend. That to basics, right? But if you want, you can request the institute; they will do it. Right? And when I come to advanced part we do split into two parts. One is project or lab. Next is theory. Theory happens on Saturday and Sunday. We are not going to do theory every day. It happens only on what? Saturday and Sunday for every day. Saturday 3 hours, Sunday 3 hours. 3 hours. And lab happens for Monday to Thursday. Again, lab, right? I can split into two parts. One is lab, I can split as weekdays lab, and one more thing I can split it as what? Weekend lab. See, any of theory happens only on weekends. It is for both. Here, lab or project, right? We can split into two things: weekdays lab and weekend lab. Weekdays lab for the students or for the candidates who can attend from Monday to Thursday, means on weekdays. So there are from working professionals who can attend on weekdays, they can attend on weekends. That is happening on Saturday and Sunday. Theory is common for both. For the weekday students, they are going to attend lab or project sessions on Monday to Thursday, and Saturday they will attend theory session morning. Afternoon they'll go. Weekend students, what they will do? Morning they will attend theory. Afternoon they will attend lab. So this weekdays lab and weekend lab both are different. Don't attend both. Both same topic will be done. You can attend either one according to your convenience. So project or lab is split into two things. One is weekdays or weekend. You can opt for any one thing. So generally, my suggestion is go for weekdays. Right? Weekends only professionals who are You cannot attend on weekdays, right? They can attend on weekends. The facility, everything will remain same. Tool facility, placement opportunities, everything will remain same. And what are the tools used, right? So we do synthesis, physical design, and sign off checks. All the three we do. So tools uses DC compiler, fusion compiler, RRC, prime time, and IC validator. So all the tools are from Synopsys. So we also train students on, see, project is done by using these tools. The tools are given to all the students during the advanced phase. Advance is going on, tools are given to all the students, and tool access is 24 bar 7. It is 24 bar 7. You can use the tool. In home also you can use it. They give VPN access. So tool access will be removed after your completion of advanced course. Not immediately. For example, advanced completes today, right? You will extend your tool access for next 15 days to practice. On request, it can be extended to 1 month also. So after the extension of tool, we'll remove the tool access. So we'll give tool access once advanced start. This 4 months will give you the tool. After course completion, next to 15 days, we will extend the tool access for everyone. After that, we'll remove the tool. On request, you can extend the tool for next 15 days. Like 1 month, you can extend the tool access. And tool access will be removed only through VPN access. Means from your home, you cannot use the tool after 4 months. After course completion, you cannot use the tool from your home. That will be removed because some students will misuse the tool. They'll sell it. They'll sell it to some other persons and all, and they'll ask other students to work on the tool. For that reason, we during the 4 months you can use tool 24/7. In home also you can use. After 4 months, yes, I'll come to query, Krishna. Right, I'll come to your queries. So you can ask me the queries. After 4 months, all right, your tool access will be removed from the home access. Not immediately after 4 months, we will extend. 15 days will extend. 4.5 months or 5 months, we'll to remove the tool access. But from the institute, you can use for next 1 year. You can come to institute, you can bring your laptop and you can use for next 1 year or till you get the job. So using from the institute, we don't have any issues. You can get, so you have the ports here, right? You can see the LAN ports here. This is the LAN port. LAN cable you can bring, that is hardly 150 rupees. You can connect to LAN ports and you can use the tool. Right? You can use a tool for any time till you get the job. Let it be 1 year, 1.5 years, or 2 years. Right? But through VPN, the tool access is only during the course time and additional 15 days. And one more tool we use only from this batch. This batch, what is using, we purchase that license also. We also use cadence tools. We also provide training at the last because we cannot confuse the students. Both if I start using red, students will confuse with the commands. So first we will work with what? Synopsis completely. See, you can ask your queries later. I'll come to that. I'll give you 5 minutes to ask all the queries. Please mute.
ఏంట్రా ఏంటమ్మా ఆ,
So cadence tools we use is like Genus for synthesis, Innovus, Tempus, and Pegasus for physical verification. These are the tools we use even from cadence, and at last we'll also give the training on this also. Even only this batch we are starting it. Earlier it was only for Synopsys tools. From this batch we are starting with also cadence tools. So first we start project with Synopsys tools. After completing the project, we also give training on See, earlier we made advance as 3 months. Now I made it as what? 4 months. So last 15 to 20 days we use to give training on cadence tools, how to use cadence tools, right? And video access will be given. So video access is given to all the students. So pre-recorded videos also given, the best from the best trainers, and live recording videos also given. Right? Live recording videos will be available for next 15 days. So today's session is done. By chance, if you're not able to attend the session due to some issues like health issue or some problem, this video will be uploaded to your portal. Every student will be given one username and password. So to your portal, the video will be uploaded. So you can see the videos after 3 hours of session completion. So today I took the session after 3 hours. You can see the video in home, and that video will be available to you for next 15 days. So live recorded videos are available. Even this live recorded videos are given for both, for basics as well as what? Advanced. By chance, if you miss the session, you will get live recorded videos. You can go to the session in the evening and you can cope up with the concepts done and you can come back tomorrow. And session will be done, mode of session. Mode of session will be online and offline, both. You can switch either online or you can switch to offline. So how it is happening now, right? Students are attending even offline and even they are attending online. They are attending online. So in the same way, the session happens. It happens on both online and offline, and you can switch any mode. If you are not feeling well today, you can work attend online. Tomorrow, if you are feeling well and if you are able to come, you can come to institute. There is no restriction. You can come to institute or you can attend from online. So facilities and support will remain same for all the modes, online or offline. And this about our course details. Right. See, timing will be generally from 9:30 to 12:30. General timing. Sometimes if timing varies, right, admin will inform you. So general timings will be from 9:30 to 10:30 for basics. For advanced also, it depends upon the strength, how much will enroll. I cannot assure the same timings for everyone because if in this batch, if I have more strength, at that time I cannot try with 70 students. We cannot take the sessions for 70 students. Then we'll split the batch into 35 and 35 or 40 to 40. We'll split the batch. So one batch will be in the morning, one batch will be in the afternoon. Theory will be same for all the students, but only weekdays lab, right? If there is more students, we'll split 40 in the morning, 40 in the afternoon to reduce the load on the servers. Suddenly all 80, 90 students using the same server, right? So I think the load on the server may increase and even mentor cannot give you the proper guidance. So we'll split the batch. At that time, the timing may vary. It depends upon the enrollments. If enrollment is less, then there will be one session, only one batch. Then it will be from 9:30 to 12:30. Session will be from 9:30 to 12:30 morning. So when it comes to placement, right, very important part here is placements. So when it comes to placements, yes, we can write all theory sessions. See, basics also we have weekdays and weekends. So weekends basics probably it may be with your convenience because weekend basics majority of persons will not attend. We will hardly we will have requests from one or two candidates. Everyone will attend on weekdays only. So if it is weekend and one or two candidates are there, it will be with your timing at what time you can join. Because if I tell Saturday morning means someone cannot join on Saturday morning, then we'll cut it on Saturday afternoon. So weekend basics right? That will be at your convenience. At what time you are available, we will do at that time, right? And here, when I come to advanced part, weekend morning there will be theory for everyone. It's common for weekday students, weekend students. There will be theory is common because theory is done by some experts. So they are available only on Saturday and Sunday. So it is done on Saturday and Sunday, right? So morning 9:30 to 12:30 you will be having theory. Then at 2 o'clock, 2 to 5 you will be having lab, right? So this lab will be from 2 to 5. So weekday students lab will be generally from, if it is one batch, it will be from 9:30 to 12:30. 9:30 a.m. to 12:30. If it's one batch, if it is two batch, one batch will be in the morning, one batch will be in the afternoon. So theory generally it will be on same. Right? It will be generally from 9:30 to 12:30, 9:30 a.m. to 12:30 p.m. So now, when it comes to the placements, right? See, placements, physical design placement is very good. There is no doubt in that, right? So placements, there are two types of companies: service-based and product-based. Everyone know, I think, right? Service-based companies hire the candidates. They will do some small amount of training and they will put into the projects of product-based companies. So what are product-based companies? Intel, Qualcomm, AMD, Nvidia, MediaTek, Google. These are what product-based companies. So they have their own employees. So most of the projects of physical design is outsourced because flow is very well developed. It's most of the project is outsourced. So means product-based companies will not take only their employees to work. They'll also take employees from service-based companies to work. So your product-based companies will pay to service-based companies, and service-based companies will pay to you. So these product-based companies, right? They will ask service-based companies to send their employees for working. So there are two companies, one is service-based and product-based. So physical design, right? There is majority of chances that you will be hired from service-based companies. Because product-based companies there will expect you to have minimum 2 to 3 years of experience, right? They'll not hire freshers directly. So they will hire only for internship from top companies. So service-based companies will hire you. They will do some small amount of training and they will put you into the projects of product-based companies. So when you go to the projects of, see, that will take 1 or 2 months or 3 months. It depends upon how much time you will take to be ready. So when you go to service-based companies, if you are very good, you can directly work in the projects within 1 month. If you are not good, it will take 3 to 4 months time. So when you go to product-based companies, the minimum salary will be 6 lakhs per month, 50,000 per month. So when you're working in the projects of product-based companies. So when service-based companies hire you, first 3 months they will train you. The time duration is not only 3 months. It can be even 1 month if you're very good, right? So as soon as when you're posted to the product-based companies project, that is your first project. So you'll be paid around 50,000 per month, right? That is what the average salary according to the queries what I'm receiving. So any that is for fresher or with little experience. I'm telling. If you keep experience, you will be even getting more than that salary. So placement is very good, and the persons who are attending sincerely our course, right? Who are not dropping in between, attending the courses sincerely, and who are doing our assignments on fly means they are not doing like that copying from chat GPT copying here and there, copying from friends, right? Instead of doing all these things, if the students are doing the assignment genuinely and they are practicing the sessions properly and they are attending mock interviews. See, we conduct mock interviews for every candidate. See, those who are clearing mock interviews, then only we give interviews outside. Like mock interview sessions will be done. So then only we give interviews from the outside company, because if the candidate who is not prepared, if we forward his resume to the companies, right, and if performance is bad, we will get affected, our reputation will get affected, and that company may not come back to us again, and other placements will be affected. See, we will conduct mock interviews first. See, mock interview will not ask any difficult questions, just basic questions. How do you fix antenna violations? How do you fix, what are the macro placement guidelines? So if the student is asking, answering in a better way or in a perfect way, so we will send them for interviews. We'll add in a job support group. So the students who are already clearing mock interviews, obviously they'll get the job. The students who are not clearing mock interviews, obviously they'll take time to get the job. So it depends upon how serious you're working and how serious you're clearing your mock interviews. So if you're not clear mock interviews, we'll support you again, right? We'll give you the PDF, what are different questions asked. So go through the PDFs, work on that, and again, mock interview is not only once. It is an mock interview is not only once. We will do mock interviews anytime if you are prepared. If your course completes, every student has individual WhatsApp group. See, you will be having WhatsApp group with all the candidates. All the candidates will be in WhatsApp group. That is separate. That is used only to inform the timings. Admin will inform you timings every week. Even the same timing is maintained, he will inform every week. That is only to inform the timings and give you the access, tool access, or if mentor is not feeling well today, no session. So only to inform that group we use. There is one more group called as individual WhatsApp group. Means individual students is created a group. In that group, admin will be there, mentor will be there, owner will be there, institute owner. So all the candidates will be present in that group. Right? So if you are not doing, if you are prepared for interview anytime, you can post in that group like, I'm prepared for interview, you can take the interview. For example, if I take interview today and your answer is not up to the mark, I'll inform that your answers are not up to the mark, prepare again. So once it is done, it's not like you will not take again. If you're prepared again you can request next week that I have prepared, take again. So you can take mock interviews any number of times till you clear. So once you clear, we add in a job support group. So those who are added in the job support group, obviously they'll get the job. So we 100% will assure you that. So for that, your effort should be genuine, and you should be attending mock interviews properly, right? So obviously, then we'll give the placements without any doubt. To answer the question of Vivek, right? Like anything you want to know before joining to the course. See, if you have the idea of VLSI, it is very well and good. If you don't have any, you need not to worry, because anyhow we are doing in the basics. CMOS basics is covered from the beginning, from semiconductor basics. What is N-type semiconductor? What is P-type semiconductor? We cover from that point. So when you're attending the basics, please free to ask your queries, get clarified, and don't attend the advance with doubts without any clarification. You get all the clarification in the basics. I think digital you already know, everyone know digital, like what is mux, what is encoder, what is decoder, what is sequential circuits, what is flip flop. See, at least you should be knowing what is difference between flip flop, latch. So what do you mean by finite state machine? So all those things you should be knowing. In Unix, it is new for everyone. I hope, right? No one is knowing Unix. GVM is new for everyone. TCL is new for everyone. So these three things is new. I hope this will be covered hands-on. Hands-on means lab oriented. So you'll understand better. So digital everyone know, even though we are doing it again. CMOS basics also, I think most of them knowing it. If you don't know also, no issues because we are doing from the basics. So total duration of course will be for 6 months, 2 months basics with 4 months advance. See, this may go to 2.5 months in some case. Means 15 days may it may be extended, or this may go to 4.5 months sometimes. It is sometimes, not always, because of, see, it depends upon the strength. If you have more students, the session timings may extend, right? Because of clarifying all the doubts. Because if I have 40 students in a batch, if all 15 students are asking doubts, if a mentor is investing time in clarifying all the 15 students' doubt, it will take more time. So in that case, the sessions may extend with 1 week extra or 2 weeks extra, not more than. So this is about the course details. Right. If you have any other queries, you can ask me now. Before going to the next topic, like what is physical design? Why we do physical design? So what is the purpose of doing physical design? So to understand that, right, we'll start the next topic. So before going to the next topic, in the course details, whatever I have mentioned, if you have any doubts, you can ask me.
Yeah, hi Srini Krishna here. So, is there any fast track batch or it's a normal batch?
So this course is 6 months, right? If you are already aware about physical design and if you want just a fast track, then you can request for admin. He will arrange for you.
Okay.
Means fast track means within what month you have to complete. Like what is the purpose of that? Whether you already know it is physical design.
Mhm. No, no, no.
Now, if you want to know perfectly, right, this much time is required. Only we doing is not sufficient, right? Only we doing the course is not
Yeah, from
sufficient. Even
track
you need
level.
to. So if you are already
Mhm.
aware and if you want to have the batches on fast track, for us, with us, videos are available only for 20 days, within 20 hours, only for 20 classes. We have completed the course. We've done many times, not regular batches. Some students who
Yeah,
request us,
exactly.
yes, do us fast track. We have done many times. So if you want like that, you can talk to admin. Admin will help you on that. So you can
Okay.
come to we can come to the institute, or you can contact on a WhatsApp. Our officials will connect you. Today Sunday, I think tomorrow they will respond to all the queries.
Yeah, okay,
On
sure, sure.
official numbers. Yes, fast track batches are available, right? And you can contact the admin. You can mention, contact the admin, the number what is given in the brochure, right? You can contact him, or you can come to the institute and contact.
Yeah,
See,
okay, sure, Srini.
when you enroll the course, right, it's not necessary that you should contact the officials here. I already told you when you are enrolling, we will create you the individual WhatsApp group. So you can put your queries there. It will be surely responded within 2 hours. Only Sunday, I think they may not respond because we have less staff working. Apart from Sundays, every time within 2 hours, they will respond to all the queries, whatever you have. So post in the individual WhatsApp group. That will be, they will respond to that. And if you don't want to post there, if you want to discuss directly, anytime it's always welcome. 9 to 6, you can come anytime. Morning 9 to 6, including Saturdays. Including Sunday also you can come, but Sunday staff will be less. One candidate will be there from the institute.
Okay. This physical design comes under the front end or back end?
It's a back end. I'll discuss what is physical design in the next couple of hours. I'll discuss.
Okay, okay, sir.
Yes, Megan, also to answer your question, right? How does the physical design, whatever the concepts we have done, right? How does the sessions what we are doing from Monday to Thursday can be covered only on Saturday and Sunday? This is what your query, if I'm not wrong. Yes, as I told you, right? The number of candidates in weekdays, if you take, it will be like 40 to 50. But if you take number of candidates in the weekend batches, right, it will be like 5 to 10, not more than 10, because everyone will want to attend on weekdays. So as number of candidates are less, we can focus more, and the mentor or a trainer who is guiding you can give you more attention. He can clarify the doubts very fast. He can cover the same concept within this time, right? So the same thing applicable. And generally, the candidates who are working on weekends, right? They are very already they are working professionals. So they have the mindset of understanding very fast. They'll understand fast, and that is what the difference is. The count, right? Strength. Weekdays we have more count. Weekends, the current batch what we are having, weekends we have only 3 candidates. So weekdays we have 40 candidates. So obviously answering to all 40 candidates doubts means some students will be working on the project from the home. If he is having doubt, which the mentor should take the session ID, clarify the doubt, and go back again to the next topic. So like that, 10 students are asking minimum for every session in weekdays. In weekends, we don't have 10 students at all. We have hardly 3 to 4 students. So thereby the time is managed. So there is no deviation in the course content for weekdays and weekend. Right? The same course will be done. As weekend we have less students, so we can cover the same topics within the prescribed time. What is covered on weekdays, right? The same topics can be covered in weekends because the strength is less. Student attending are very less count. Hardly 3 to 4 will attend on weekend. Yes, the first session tool installation. First session, right? Tool installation for advanced batches. We did tool installation or for Unix also. Tool installation. We have 40 students in weekdays and 5 students in weekend. For weekend batches, tool installation completed in half an hour. All 5 installed tool, everything is completed. For weekdays, right? Even 3 hours was not sufficient because different students were coming up with different queries. So my tool is like this. Mine is not Windows. Mine is uh, some other operating system, Unix operating system. Mine is some other uh, operating system, and they come up with different doubts. Right, my screen is not coming down. It's stuck in between. They come up with different doubts. So even 3 hours was not sufficient for weekdays batch to complete the tool installation, and for weekends it completed in half an hour because we have only 5 candidates. All the 5 candidates doubts were cleared and it is completed. So thereby the session timing is managed. So it depends on the load, right? How much load the mentor has. Weekdays and weekend days instructor is different or same person. It depends on the load, how much load the mentor has. If mentor is having more load, then weekend and weekdays will be different. If mentor is having very less load, then both will be same. So generally they will be same. The same mentor who is handling on weekdays, he will also handle on weekend. The same mentor will be there, but if the load is more on the mentor, like see the current batches what we are handling, right? The last 2 batches what we have strength of 120. The September batch or October batch, whatever we have strength of 120. So the 120 batch, 120 students were to split into 3 batches. So load is more on the mentor. But the current batch, the previous batch, what we had, that is having strength of 40. The load is less. This batch is almost around 40 to 50. So it depends upon the load. If load is less, the same mentor is used on weekdays and weekend. If load is more, we cannot use. We should use some other mentor to do it on weekdays and weekend. Means the same mentors. There is no, we are not going to replace with the new mentors. So we have 2 to 3 mentors for physical design. So if we don't have load, one mentor will be guiding on basics. He'll be doing basics. One mentor will be doing physical design. If load is less, if load is more, we will remove the mentor from the basics. Basics someone will do. So we will ask that mentor to do what? Physical design. So thereby we will manage the load of the mentors. So if I want to get in place product-based companies, will guidance be provided or the institute give us opportunities to sit in these companies? To answer these questions, right, I've already answered. Product-based companies will never hire the freshers. At least you need a 2 to 3 years of experience, minimum 3 years, to get into product-based companies. And if you tell that, if you give any reference like these persons are working in product-based companies as fresher, they will be hired through internship from top institutes. They'll hire from top institutes like NIT, IIT, right? They'll hire from there, and they'll hire as internship, and they perform well in internship. They'll be observed there, right? So you should be showing experience to get into these companies, and if you show the experience, right, you can easily get into the companies, product-based companies. If you see, we have some candidates like some candidates will approach us, sir, you train us, and I will put the experience. I have the experience. I have experience in the same company in different domain. For example, when you go come out of a company, right, they will give you, you are an engineer of this company, but they not mention which domain you are. So yeah, I have experience in different domain. I want to jump into physical design, or I want to jump into some other product-based company's physical design domain. You support for us, then obviously we have supported many times. They've also got the jobs in many product-based companies. But keeping this experience, right, you have to discuss with the institute how to keep the experience. If you have 3 years of experience, then you can attend the interviews product-based companies. So any candidate who is approaching with that experience, we have supported him. See, the problem with product-based company is not our course content. The problem is what is their criteria. Their criteria is you should be having minimum 3 years of experience. So to be very frank, you having year gap in between, you can keep, you are having 3 years experience. But product based companies will identify that, because only experience letter doesn't matter. Form 16, your PF statement, everything will matters in background verification. For example, I have year gap and I mention somewhere I'll take the fake certificate. I tell that I have 3 years experience. So only experience certificate doesn't matter, right? It is like your previous company's salary statement, everything matters. So product based companies will ask everything. The background verification will fail. But service based companies, they know even though you are fake, they'll take you. That is not a matter for you, because not all, but some companies will take you because ultimately they require talent. Right? They need a talent to work. If they see the same talent in you, and even though they know that you are fake, they'll take you, because they need a talent and they need a person to work on the projects of product based companies. You have a talent, you are showing the same talent in the interview, they will take you even though they know that you are not really that is the difference why you cannot enter into product based companies even with fake experience. See, not only the students who want to train, they will attend the courses. The students who are already doing internships, right, in product based companies, who they also enrolled, many of them have enrolled, many of them have enrolled in some other, not directly in physical design, like TCL training, Perl training, Python training, because when you working as internship there, they will ask you to write some programs on VLSI using Perl, Python, or TCL. So they have also enrolled, they have also discussed their experience, and they also got good reviews or they have also got good remarks from their uh, team leads. So they also enroll the courses. So few students 2 years back they've enrolled for physical design itself when they are doing an internship in companies. So company they'll ask internship means it is not that every time they will support you. Then also you need a knowledge of working or some basics of Perl Python to do some activities, right? So then students even they have enrolled when they are doing internships to these courses. So at last to be concluded, if you have proper experience, if you discuss with the proper experience, how to get the proper experience with the institute, then you can easily attend the interviews of product-based companies. And if you're not sure about your previous experience, you are 2024 passed out and you cannot claim 3 years experience, right? Because your mass card says that you are 2024 passed out. So all those things will come into picture. And if you have reference, you can get into those companies. So product-based companies, the problem is they'll hire only experienced candidates. They'll not hire the freshers. So they will hire only through internships. Service-based companies will hire you after 3 years of experience in working in service-based companies. Then you can jump to product-based companies. Generally, how hiring happens to product-based companies? So you will be working on the projects of product-based companies, right? For example, you are working in a project of Qualcomm. 6 months you have worked. Your performance is good. They will renew your project. Next, you will work for 1 month. Next to 6 months. Next 6 months, you will work. Entire 3 years, you have worked there only in the project. You are from service-based company. 3 years, you have worked in the projects of what? Qualcomm. You have good relation with all the managers, team leads, everywhere. Then directly we can get a job there, and your that manager of that company also seen you how you are performing. They directly observe you. That is how everyone is getting the job in product-based companies. When you work in the service-based companies for more time, after that you can directly by seeing your talent, they will only hire you. They only come up with the new offers if you're performing very good in the projects. But your performance should be good, right? Then they hire you. Okay, I will stop with all the queries. Right, I'll go to the next topic. So diploma ECA students are eligible for VLSI. No, I think right. You should be having a minimum B degree for physical design course. So no company will allow diploma student for physical design, but for layout it is possible. So please talk to the institute once. So as I am in physical design domain, I can clearly tell that it's not possible. At least you should be having a BE degree. Without BE degree, it's not possible to get into that. But with layout it is possible because few layout engineers with the diploma background they are working already. Layout or PCB design, it's possible. But with physical design, it's not possible. You should be having BE degree compulsory. So front end and back end, which is better? See, both are better in terms of job opportunities and the salary. Both are having equal stress and equal salary, right? But only thing is, if you are very good in coding, see what is happening in your front end is RTL coding. You should be very strong, and you should be very strong in System Verilog. System Verilog is almost equivalent to your C++. Understand the concept like Ethernet protocol, understand Ethernet protocol, write a program or come up with a test program or test results or test plan. How do you test this Ethernet protocol? Come up with a test plan. After coming up with a test plan, right, write the Verilog program, system Verilog program with a test plan. If you are very good in understanding this analytics and understanding how to come up with a test plan, how to write the system Verilog program to meet this test plan. So if you're very good in that, then you can go for front end. Means you should be very good in coding. In physical design, extensive coding is not required. In physical design, coding is not required. Physical design deals with Understand the problem. What is the problem? Come up with a particular solution. What is the solution for that? So physical design, more and more you will become expertise when you become experienced. If you work on 10 projects, right, you will become very expertise. So physical design, all the expertise will come with experience. Because now what I can do is, when I was 3 years before or 4 years before, if I see one problem, I was not able to understand what is the problem. Now if I see the problem, I can immediately come up with what is the solution for that. How I got that thing? Through experience. So with experience working on different projects, you'll get expertise in physical design. So extensive coding is not required. But understanding the concept is required. That's it. Proper understanding of concept, what is a solution, and how to implement a solution in tool. That is what you want to understand in physical design. But in front end, right, you should be good in coding. So if you're good in coding, you can go with front end. If you're not good in coding, then you can go with physical design. It's your choice. And job opportunities and salary point of view, both has same. Both are same it. So earlier front end was like front end was having upper hand compared to physical design because it's very difficult. Now it's not like that. Even we have chat GPTs. It is also going to help us. So physical design is very easy in industrial point of view. Doing in the training session only is difficult because we do all the step by step in the training here. But in industrial point of view, physical design is very easy. But why? Because physical design is semi-automated. Just run one file. That file only will take from starting to end. Complete flow it will only take. Not only physical design, right? Even the flight. Flight also you can keep in auto flight mode. Flight only will take you from source to end destination. You have pilot. What is the role of pilot in flight? Nothing. Sit simply. Autopilot mode will take from source to what? Destination. Then what is the role of pilot there? Why pilot is required then? If at all there is a turbulence, bad weather, heavy rainfall, cyclone, right? You want to land in a cyclone. Auto flight will not work. You have to manually land it. So whenever there is a issues, then only the pilot should take care. Or else pilot is not required. Same thing physical design is. Automation will take you through entire flow. So whenever there is an issue, then you have to look into that. Or else it's not required. So physical design is industrial flow of physical design is very easy. But industry is having complexity. Complexity means you will be working with a cell count of 3 lakhs or 30 lakhs. Here in the training, we are working with 50,000 or 60,000. Because we cannot work with the 30 lakhs here. 30 lakhs, if I work, the runtime is very huge. One command will take 4 hours to work. Industry, I can wait for 4 hours. But here in the training, I cannot wait for 4 hours because my training time only is for 3 hours. So if I use more cells, it will take more time. So for that purpose, what we do is we work with less cell count, like 60 to 70,000. But industry works with 10 lakhs to 30 lakhs range, right? So the complexity is high in industries, but flow is very easy. Flow only will take care everything. Only if there is a issue, you have to come into picture. That is a physical design. Nowadays, physical design is like that. So compared to front end, physical design is a little bit easy in terms of easy. We measure right, which is easy. Physical design is easy. Front end is what I told, right? Understand any particular protocol, Ethernet protocol, not only Ethernet. We have many protocols, Ethernet, SDRAM, many protocols. You understand that, come up with a test plan, write a program for test plan, verify the RTL. After verifying the RTL, come up with the test results. So front end is difficult compared to physical design. But if you are very good in programming, it is easy. So that becomes your choice. Apart from that, the salary point of view and design opportunities both are same. If I go one step extra, even DFT is very easy. compared to physical design. You have one more course, DFT. Right? It's very easy. Layout is still more easy. So it's up to you. All the courses have equal job opportunities, but only salary point of view it varies from layout engineer to physical design engineer. When you become experienced, highly experienced candidate of layout may get different salary, and physical design engineers may get different salary. That matters only if you are 10 years experience. After 10 years only, this difference will come. At the beginning, everything is same. So physical design engineer will get more salary when you compare with layout engineer after 10 years, not now. At beginning, both are having same salary. Even same with DFT also. At the beginning, everything is same. So if I come with the easy, layout is very easy. Next is DFT. Next is physical design. Next is front end. Front end is difficult compared to physical design. Little bit difficult, not very difficult. So it's up to you. How do you take it? Job opportunities remain same. Salary remains same at the beginning. So it is going to vary when you have more experience. At a time only it's going to vary. At the beginning it remains same. So I think I have hoped I have answered all the queries, right? And if you have any queries, right, we'll reserve or we'll keep it at the last again. So this is our course content. So we have two things, basics and advanced. First we'll start with basics. After 2 months we'll start with what? Advanced part. If any candidate who don't want to enroll for basic, if you know all these things, someone will be knowing because someone is already part of VLSI design and but in the different domain, not in physical design. So they'll be knowing all these things. And you can skip this directly, you can enroll for advance. It's your wish. And the person who is from directly from the UG courses, then they should attend the basics compulsory. Yes, obviously, right? We have collaboration. See, any company is having requirement, right? Obviously, they will going to personally mail us. So you can ask in the WhatsApp group what are the companies we have collaboration. Our manager will respond for that. Right? So any company is having requirement, they will personally mail us. We have this much requirement. Send us the resume. So we will collect the resume from students after taking what mock interviews. The students who are cleared mock interviews, we will collect the resumes and we'll forward to the interviewer. So interviewer will schedule the interview online and he will decide whom to select. So this process continues. If you fail on the interview also, no issues. You will be getting next opportunities till you get the job. Yes, online students, whether my voice is breaking for everyone?
No, sir.
Yeah, what is physical design? Right? Next to come to what is physical design. So we'll get into these topics now. Technical part. So first I'll discuss with what is physical design. Then I briefly discuss what is our course content of advanced part. At last again I'll take what is your queries. This is what my intention of discussion today. So many will be knowing what is physical design, what we do in physical design. But for the freshers who doesn't know what is physical design, I want to take a few minutes to discuss what is physical design, why we do physical design. See, VLSI stands with what? Very large scale integrated circuit means we are going to integrate many transistors on a single die. That is called as what? IC. IC means what? Integrated circuit. See, whatever we are doing here, everything is to fabricate this IC. So to come up with an IC, right? We are engineers are working integrated circuit. What is integrated circuit? This is integrated circuit, right? This IC. So in this IC, how many gates we have? You know what is gates? AND gate, OR gate, XOR gate. Right? How many gates you think it will be having? Crores,
Million.
crores of gates. Not even in million. Right? We block level only. We work in million. It will be crores of gates. 3 to 4 crores of gates will be present in this IC. Hardly this IC will be in centimeters. So we have chips, right? Chips of Intel, chips of Qualcomm, this mobile phone chip. All these chips are having almost crores of gates inside. So now, when I talk about this IC, right? IC, getting IC in the market has two things. One is IC fabrication, next is IC design. So two parts we have. So IC fabrication and IC design. So IC fabrication, where it happens?
Foundries.
Yes, correct, right? IC fabrication happens in foundries. So foundry is a place where IC fabrication happens. That place is very neat, clean, and they have machineries to fabricate IC because size of transistor. You know what is transistor, right? MOSFET. It is in nanometer. Nanometer means 10 to the power of minus 9. In the scale, smallest unit is millimeter. 10 to the power of minus 3. The 10 to the power of minus 9 means in the scale whatever I have. If I have scale, right? This is called as what? This is millimeter. If I cut this millimeter into 1 lakh times, that will become what? Nanometer. This much if I cut into 1 lakh times, so even transistor I cannot see through my direct eyes. So we should use some electronic microscope to see the transistors also. The size of transistor is less than the size of bacteria. So foundry is a place where IC is fabricated, and getting a foundry in any place is very difficult because it requires a huge investment, and India doesn't have sophisticated foundries. India has foundries, but we don't have sophisticated foundry. Means to produce large extent of chips per day, we don't have. But we have foundries for research purpose. Even ISRO is having, and some IIT NIT is having, and few companies are also having foundries. But it is not. It's only for research and to produce IC in small extent. But to produce IC in large scale, so we don't have sophisticated foundries. So other countries like Taiwan, Japan, USA, uh, Korea, so those countries have sophisticated foundries because investment is very huge. See, foundry building and foundry should be very neat, clean. 1,000 times should be neat and clean than the operation theater of hospital. A small dust can cover hundreds of transistors. So it should be very neat, clean, pure distilled water should be used to fabricate IC, and many chemical procedures we use in fabrication. So hazard management unit should be implemented. So in India, we engineers never work in IC fabrication. We work in what? IC design. So IC design happens by using EDA tools. EDA stands for what? Electronic design automation tools. We use this EDA tools. In EDA tools, we work and we design an IC by using EDA tools. So these are some EDA tools, right? And I hope in UG everyone has used FPGA or Vivado board. So you have EDA tool called as Xilinx. Xilinx is also one of the EDA tool. So EDA tool is going to help us to design an IC. So we engineers we use EDA tools, and these are the EDA tools, electronic design automation tools. So two major vendors for us is Synopsys, and one more is what? Cadence, for especially for physical design. And we also has one more vendor called mentor graphics. Even we have tools for mentor graphics also, but for physical design, mentor graphic tools are never used. So we are not doing it. Like mentor graphics has Nitro tool for physical design, but it's never used in industry. Industry either uses Fusion compiler or Inverse. Few company uses Fusion compiler, few company uses Inverse. So mentor graphics, some tools are used like Caliber for physical verification. We have Caliber, even that is used, and for few front end and for few DFT, mentor graphic tools are used. So we have all the tools, but we use tools from Synopsys and Cadence. So we engineers work on EDA tools. So when we work on EDA tools, what we are going to give to fabrication unit for fabricate IC? Can you tell me? What design engineers, we engineers work in EDA tool? Means EDA tool is a software tool again. We design IC using software tool. After designing an IC, what we are going to give to foundry, so that foundry is going to fabricate IC for us. What we will give? Yes,
GDS2 files, sir.
we are going to give GDS2 files. So what is GDS? Graphical data stream, information interchange. So what GDS consists of? What is present in GDS?
Layout information, sir. That
Yes,
structure of
correct.
the cell.
Good. So it has layout of cells. See, cells means it is gates. Under terminology, what we use is instead of cells, instead of gates, we use what? Cells. Layout of cells and its connections. Right. So you know what is layout? Yes. Everyone know what is layout? So if you doesn't know layout, right, then you have to attend what your CMOS basics. We are going to cover what is layout. Just I give one example of layout. If you take your CMOS inverter, so CMOS inverter has what? It has PMOS,
Combination of CMOS and NMOS.
NMOS, right? This V in, what is this? V out, this is VDD. So when I write the fabrication of this, we have P substrate, right? What is this? This is your P substrate. In P substrate, what I can fabricate? I can fabricate only NMOS. So I can fabricate NMOS source, NMOS drain, right? This is N type semiconductor, N plus. But to fabricate PMOS, what is required? I have to form N well, right? First. So every company uses N well technology. So PMOS is formed in what? N well. So in N well, I am going to form PMOS. I have PMOS source and I have what? PMOS drain. So this is PMOS. This P plus, this P plus. So on top of this, we have what? Silicon dioxide. On top of this, we have polysilicon. Polysilicon is your gate, right? This is gate. This is what? Source. This is drain. Again, this gate. This is anything I can interchange. This I'll make it as drain. This I'll make it as what? Source. This is the structure of your CMOS. So this is not a layout, right? What you see from the top, that is called as what? Layout. So top view of the IC is called as what? Layout. So when I draw the layout, how to draw? First I have to draw what is P substrate. What is this? P substrate. Inside P substrate, what is present? This N-well is present, right? So write N-well. So this is your N-well, purple color. So inside n, well, inside P substrate I have to form what? N plus source and n plus what? Drain. So that I will form. So form n plus source and drain. So this is a diffusion. This n type semiconductor, n plus source. So in between I'll cross with what? Polysilicon. So any diffusion, if I cross with polysilicon, right? What happens? A transistor is formed. This is source. What is this? Is drain. This is NMOS. What is red color? Gate. And one more thing, right? You have PMOS also. And in between, if I cross like this becomes a gate. This is P plus, right? P plus source, P plus drain. Now I have to see this gate, right? Gate is an input. So here, gate of PMOS is what? Shorted. So short that. Gate of PMOS and gate of PMOS shorted. By using polysilicon only, I'll short. It is shorted. After shorting, give one metal connection right here. Current to one metal. You connect to one metal. So when polysilicon and metal are connected, I use one type of connection called as what? Contact cut. Whenever semiconductor and metal is connecting, we should use a material called as what? Contact cut. So this is a contact cut. The blue color is what? What is the blue color? Metal. Right? This blue color is metal. So this is your V in. Now, what is required thing here? Source of your PMOS is connecting to VDD. Source of your NMOS is connecting to what? Ground. We will make this connection. So this is a source, right? This is a source. So first I have VDD and VSS rail on the top. Here I have VDD. Here I have what? VSS. So we have VDD and VSS. And now you make a connection, right? Source of PMOS connect to VDD. Source of NMOS connect to what? VSS. So whenever, again I told you, right? This source is a P-type semiconductor. This source is what? N-type semiconductor. And blue color is what? Metal. Whenever metal and semiconductor are connecting, we should use what? Contact cut. So what is this? This is your VDD. What is this? This is your VSS. Last step is what? Your drain and drain is connecting. Right? This connection I have to make. I will make the connection here. This drain is connecting. This drain is connecting. By using metal layer, I will connect. Right? And I should use what here? Contact cut. Right? Because drain is a diffusion. P-type semiconductor. I will use contact cut here. What is this? This is your V out. So this is a layout of what? This is a layout of CMOS inverter. So this is only one inverter, right? For example, I have layout of another cell here. I have layout of another cell here. Here I have layout of another cell. So output of this cell is connecting to what? Input of this cell. Output of this cell is connecting to what? Input of this cell. So here I have layout. Here also I have what? Layout. So connection of layout of all these cells is present in what? Which file? GDS file. This GDS file has this layout of all the cells. How many cells? Crores of cells and their connection. So that is present in your GDS file. So at last, from the design team, we should get GDS file that it should be given to what? fabrication team. That is the final role of design engineers. I have told only design engineers, right? There are two types of engineers again. What is that? Fabrication and design. See, fabrication engineers are not purely electronics; they are chemical engineers, because entire fabrication is chemical driven. Oxidation, etching, uh, chemical, mechanical polishing, everything is chemical driven. So the persons who are working in foundries are chemical engineers with electronics knowledge, but the persons who are working in design is what? Electronics engineers with software knowledge. So we should be having software knowledge, right? Because we are working on EDA tools. So these EDA tools can understand only TCL, tool command language. So you should be knowing tool command language. If you know tool command language, then only you can work with these tools, or else you cannot work. So to understand the role of physical design engineers, so we have to understand what is ASIC design flow. So what is ASIC design? What is the full form of ASIC? Application specific. So integrated circuit is for specific application. So we're designing IC for specific application. So we have to work on ASIC design flow. This is what the design engineer is going to follow. So design engineers, again there are many types, right? So first is ASIC design flow starts with what? First step, it starts with specification. Specification of IC. So what are the specification requirement? What is IC requirement? What are the blocks present in IC? Right, like this. So we have to come up with architecture. What block present in IC? We have GPU, USB, MEMS, Bluetooth, RF module, means radio frequency transmitter and receivers. RF means so speaker unit, display, sensors, control unit, PLL is used to produce different clock frequencies. So what are different blocks required in an IC? First we have to decide, and out of that which is done by digital design, which is done by what? Analog design has to be differentiated. So analog design engineers will work on analog blocks. We digital design engineers we work on what? Digital blocks. So in specification we should be knowing number of blocks, frequency of each block. Chip architecture team will do this one, right? Frequency of each block, with each block is working on which what frequency. Power, estimated power consumption. So what may be the estimated power consumption? Area, what is area of chip? So all those things, right? We will they will take discuss in specification steps. All the top guys are involved, right? That company top guys are involved. Marketing team is involved. Business team is involved. Technical team like architecture team is involved to decide what is the requirement of chips. So generally chips are reused, right? So what are chips? If the company is coming up with new chip means nowadays it's not that they are building everything from scratch. Already previous chip whatever they have they are reusing it. They are rebuilding with some extra features. That's it nowadays. So there is none of the ICs are built from the scratches again, right? Next is after specification. After we know what are the modules we have to implement, we should start implementing this ALU module, ASIC module, GPU, CU, right? PLL, PLL we cannot implement. Analog engineers should implement because PL is analog circuit. Right? So what we do is next is design entry. Means start implementing the design. Each block you start implementing. That is called as what? Design entry. So how do you do design entry? Okay, I have given implement one CPU. or ALU, arithmetic logic unit. How do you implement that? Whether you directly start taking the gates and you start implementing it. No, you will go with what? RTL coding. So you will use either Verilog or VHDL to describe the design. So why Verilog or VHDL? Why not directly? We cannot go into structure. Why I should use Verilog or VHDL? For example, I told you implement one mux. Why you have to start with Verilog or VHDL? Or I told you implement one D flip flop. Why not directly with gates? Okay, I will ask you one question. Like, how many can you tell? What is the how to implement 2 is to 1 mux or 4 is to 1 mux? I'll go with 4 is to 1 mux. I have 4 is to 1 mux. What is this I naught? I1, I2, I3, one output. I have two select lines. One is S naught, one is what? S1. This 4 is to 1 mux. So I'll ask one question, simple question. Implement this 4 is to 1 mux by using gates. How many can you write a circuit? By using basic gates, right? Implement it. Or first implement 2 is to 1 mux by using gates. Then by using 2 is to 1 mux, implement what? 4 is to 1 mux. Any method. How many of you implement? Okay, none. Right? I don't know. So if I ask you to explain the behavior of this mux, whether you can explain? If S1, S0 both are 0, 0, what is output? What Y is going to take? Y is going to take what? What is present on I naught? If it is 0, 1, what Y is going to take? I1. It is 1, 0. What Y is going to take? I2. If it's 1, 1, I3. This is a behavior of mux. So everyone remember behavior, right? In the truth table you will remember. But no one is going to remember what is present inside the mux. What is structure of the mux. So remembering behavior of circuit is easy. But remembering the internal structure is difficult. So this Verilog or VHDL help us to design or help us to describe a circuit in the form of its behavior, not in the form of circuit, right? Not in the form of structural. So how to implement in the behavioral form? Direct use if statements, right? If S equals what? 0, 0, I should use like two tick binary 0, 0, right? Directly I'm writing 0, 0 for simplicity. So y is going to take what? I naught. Else if S equals 0, 1, y is going to take what? I1. Else if S equals 1, 0, y is going to take I2. Else y is going to take I3. So entire behavior I wrote by using if statements, or you can write by using what? Case statements. So Verilog or VHDL uses if statements, case statements, procedural block to describe a circuit in its form of behavior, how the circuit behaves, not in the form of structure. Structure means what? Gate level implementation. So Verilog or VHDL, I can see if it is a bigger program. Generally, we will not implement like this. It's a bigger program. How the behavior is, for example, I have a bigger design. How behavior is captured? It's very bigger design. For example, your ATM machine. How behavior is captured? FSM, right? First, your design team will start writing FSM, finite state machine, and they will decide each state what operation it has to do. For example, you have ATM machine. ATM machine will be in the reset state always. If you insert the card, right? If the card is not inserted, then to the chip, right? What a chip I have. If card is inserted, I have one port here. To this port, always zero signal will be coming. If card is inserted to this port, I'll get one signal. So if the zero signal is coming, I will be in what state? Reset state only. If I get one signal, then I'll go to next state. What is the state? Pin entering state. If pin is entered properly, see pin is entered, then what I have to do in this state? I have to wait till person is entering pin. If person is not entering pin for longer time, then go back to what state? Reset state. Then I'll go back to reset state. Or if the pin entered, again I have to check after entering pin. I have to check whether pin entered is correct or not. If pin entered is correct, it's okay. If it is not correct, again go back to which state? Reset state. So two things I have to check here. If pin is not entered for long time, go back to what? Reset state. If pin entered is wrong, then you go back to what? Reset state. If pin entered is correct, then go back to what? Amount state. Right? How much amount you want? I'm reading basic machine. Other machines may ask you whether you want to take the amount or balance inquiry, something and all. But I'm going with basic machine. So how much amount you want? So when a person is not entering amount for longer time, first thing. Second thing, if he is entering the wrong amount means if he is entering the amount more than its balance. Third thing, if he is entering the amount like 433 rupees, which is not multiple of 500s or not multiple of hundreds, then my ATM machine cannot dispatch the amount. So if these three conditions is satisfied, then go back to what state? Reset state. Print the error message and go back to what state? Reset state. The meaning is whatever amount you have entered is more than your balance. Or the amount is, what is second thing? Amount is if the person is not entering amount for longer time. Second one is amount is more than the balance. Third one is amount is not multiple of hundreds or zeros. So if anything is true out of all these three, go back to what state? Reset state. If amount entered is correct, alright, then go back to which state? Amount dispatch state. Amount dispatch. If amount is not dispatched, be in the same state. Till amount is dispatched. If amount is not dispatched, be in the same state. If amount is dispatched, go back to what? Reset state. This is called as finite state machine. So in each state, what operation we have to do is known, right? What my chip has to do. So in the reset state, what my chip has to do? Wait for the card insertion signal. If I get card insertion signal, go to which state? Pin entering state. When pin enters state, when the person is not entering the pin for predefined time, go back to what state? Reset state. If he is entering pin, then you validate the pin. The pin is correct or not. If pin is wrong, again go back to what state? Reset state. If it's correct, then come to what state? So the role of pin entering state is done. Wait for pin. If pin is not entered, go back to reset state. If pin is entered, validate the pin. If pin is correct, go back to amount state. If pin is wrong, go back to what? Reset state. So each state, what it has to do, the behavior is known. So when we have bigger designs, what my RTL engineer will do, he will decide this bigger engineer, he will divide the bigger engineers to different states. In each state, what I have to do. He'll start coding the behavior of what each state, what each state has to do. That is how the RTL is working. RTL designers work. They implement every design by using what? FSM, bigger designs, finite state machine. So I can tell after coding the design by using Verilog or VHDL, my design is in what form? It is in Verilog or VHDL. I can tell it is in what form? Behavioral form.
behavior form.
It is in behavioral form. Behavioral form means if statements, case statements. Whether this form I can send to Foundry. Now Foundry requires what form? Layout form. So next comes one more step here. Functional verification. See, all these are, this is a chip architecture team. This is one of the job in VLSI. This is a RTL designer team. This is one of the job in VLSI. You can even become this is a front end. Right? If you know proper Verilog and system Verilog, you can become RTL engineer. Next is functional verification engineer or design verification engineer. Both are same. Or it's also called as design verification. So what is the role of this engineer? So verify functionality of design, right? Verify functionality of design by applying what? By applying test cases. So this is called as functional verification or design verification. Means I have mux here. How to I have my RTL engineer has written the code for mux like this. So how to verify this is working as mux or not? I have mux, right? So I will take an example of 2 is to 1 mux. Just so if I take example of 2 is to 1 mux, I have only one select line, two inputs I naught and I1, one output. Right? I have I naught, I1, I naught, I1 select line and what? Output Y. If 0, 0, 0, if all three are 0, what is output? If select line is 0, Y is going to take what? I naught. What is the value of I naught? 0. 0, 1, 1. What is output? If select line is 1, my Y is going to take what? I1. What is the value of I1? 0. 1, 1, 1. What is the output? If select line is 1, Y is going to take what? I1. What is the value of I1? 1. So this is called as test case. Each combination of input is called as what? Test case. So apply this test case. Check what output you are getting. For your RTL code, what output you are getting. If that output is same as your expected output, then your RTL code is correct. Or else or your RTL code is wrong. So apply this in different inputs. That is called as what? Functional verification. So verify functionality of design, which is in the behavioral form, by applying what different test cases and check what is the output. If both outputs are matching, then it's fine. Or else you can check the outputs are, if you can tell outputs are not matching. So what is the next step? Synthesis. So your design is in the behavioral form. Convert this behavioral form into what? Gate level form. First step. Directly we are not going to layout form. Whatever is present in behavioral form, convert to what? Gate level form. That is called as what? Synthesis. Right. So synthesis is nothing but converting RTL code into gate level netlist. That is called as synthesis. Means whatever RTL I have to convert to gate level form. Right. So then what are the inputs for synthesis? Synthesis tool, right? Here I'll mention both the tools. So we use Genus from Cadence and we use design compiler from even FC shell can be used. Right? DC means design compiler or FC shell from Synopsys. This is a tool we use for synthesis. So tool will do synthesis. But for tool doing synthesis, we have to provide proper input. So what are the inputs for synthesis tool? So one of the input is your RTL, right? RTL is what file? It is a .v or .vhd. .v means it is .v is for extension for Verilog. .vhd is for extension for VHDL file. So RTL. RTL as what? Design in behavioral form, right? Design in behavioral form. What is the next input? Hmm? Timing constraint is also one of the input. Next, apart from that, I'll write that timing constraint.
Window.
Libraries, right? For logical synthesis, libraries, library file, or it's also called as liberty file. That is .lib. Right? The extension is .lib, file extension. This is one of the inputs. So what this file consists of? See, my synthesis tool is converting this RTL to gate level netlist, right? What gates I have to use to convert? That is told by this liberty file. What gates present in liberty file? Only those gates I can use. So while converting RTL to gate level netlist, what gates we have to use for conversion? All the gates present in liberty file can be used for conversion. So in the liberty file, what I have? So for all standard cells, we have timing and power information. We have area, timing, and power information. Means standard cells. What do you mean by standard cells here? Standard cells are the cells like AND gate, OR gate, XOR gate, NAND gate, NOR gate, NAND, NOR gate, D flip flop, MUX, inverter, buffer. Sometimes you can also have half adder, full adder, right? These are the gates. Half adder, full adder is not there, no issues, because you can build half adder, full adder from what? Gates. But in some libraries you will be having half adder, full adder also. For all these gates, basic gates, DFF means what? D flip flop. So we have what information? Area. Each gate is taking how much area? Layout area. What is the area of layout? What is the timing? Means what is the delay of each gate? How much delay it is taking to produce the output after changing the input? How much time it is taking? Power. How much power it is consuming? Each gate is consuming how much power? So all those information is present in which file? Liberty file. That is .lib. So last file is third file. What we use is HTC file. .stc. Synopsis design constraints file. So this file has constraints like after synthesis, your design should work with what frequency of clock. See, you have many synopsis constraints commands. So for the time being, you can understand that you have clock period. How much, what clock you are using for this design? What is a clock period? Right? Like other information like clock uncertainty, clock transition, set input delay, set output delay, set load, set driving cell. So set false path, set multi-cycle path. If anything is there, right? All these things, constraints, timing constraints on the tool. If you want to put anything that is present in HTC file, that you will learn in advanced part. Each command you will learn why we use it. So means in brief, I can tell when you convert RTL to gate level, right? While converting, you have to convert in such a way that you are meeting this timing constraint. So your design should work with this clock frequency. You convert in such a way. Right? That is what you're telling to your synthesis tool. So synthesis tool, it will pick the cells from this liberty file. It will convert your RTL to what? Gate level netlist, means gate level connections. So you have come one step down now, right? From behavioral, you have come to what? Gate level. So what is output of synthesis? See, you will study everything about synthesis also, like water synthesis steps, water synthesis optimization techniques, like ratio retiming, FSM decoding, logical restructuring, means auto ungrouping, boundary optimization. All these steps you will learn in synthesis. But I am not covering it now because that itself will take 2 days to do. But what is output of synthesis? So output of synthesis is what? Gate level netlist. So this gate level netlist is also what file? .v file. It's also Verilog file. Verilog or VHDL file. Then what is the difference between that and this? What is difference between your RTL and gate level netlist? RTL is in behavioral form. You can use any syntax of Verilog in RTL. RTL should not have system Verilog. RTL should have purely Verilog. But gate level netlist cannot use assign statements, procedural blocks, if statement, case statements. Gate level netlist should have gate and its connections. That's it. Only this information should be present in gate level netlist. RTL can use any statements. For example, right, if you have this gate level netlist, this gate level diagram. So this is having, you assume one OR gate that is connecting to one AND gate. Just assume that this is your gate level diagram after synthesis. I have inputs like M, N, O. Output is what? P. This is a gate. Right? This gate is having A, B input. A, B as pins. Output is what? Y. This A, B pin. Output is Y pin. This is A pin, Y pin. So this is this. The name of this gate in the library .lib, right? I have shown .lib here. The name of this cell in the .lib is, we assume it is R2. Here it is and 2. 2 means 2 input OR gate. It is what? 2 input AND gate. So name of this is inverter. And these intermediate signals. These intermediate signals we call it as wire. This N1 wire. What is this? N2 wire. Net. So how to write Verilog program for this? So your Verilog program will start with what? Module. Module name. Module name I'll take as temp. I have to declare what? Inputs. What are the inputs? M comma N comma O comma out. Next, what is output? P. Next, declare inputs. Inputs are M comma N comma O. What is outputs? Output is P. Next, I have to declare wire. Wire means intermediate signals. What are wires? N1 and N2. I have two intermediate signals, N1 comma N2. So we have terminologies here, right? So this is my block, entire block. So input and output of block is called as what? Ports. So here M, N, O, P are called as what? Ports. Input and output of a cell is called as what? Pins. So here A, B, Y is called as what? Pins. Because it is input and output of a cell. M and O is input and output of a block. It's called as what? Ports. So after writing this, right, in my gate level netlist, I should be having only gate and its connections. So first I have to declare first gate. What is the first gate? Library name or R2. My synthesis tool will give one instance name. The instance name for this OR gate is U1 because I can have n number of OR gates in the design. From one OR gate to another OR gate, I should be having some different naming convention. So this naming convention is different for different gate. This instance name. So my synthesis tool will give this is U1. What is this? U2. What is this? U3. So this is a library name. This is an instance name. After that, you have port mapping. Port mapping means this A pin. Dot A means this A pin of your OR gate connecting to which port? M port. In the bracket, I have to write M. comma. Next dot B. B pin connecting to which port? Which port it's connecting? N port, comma. Dot Y. Y port of your AND gate. Sorry, OR gate. Connecting to which net? N1 net. Right that. Means I'm writing where my pins are connecting. A is connecting to which port? M. B is connecting to N. Y is connecting to what? N1 net. Next cell. I don't have space here. I'm writing here. What is next cell? And get two input. What is the instance name? U2. So A pin where it is connecting? N1 net. B pin where it's connecting? O. Y pin where it's connecting? N2 net. Last, what is I have? Inverter. What is the library name? INV. What is the instance name? U3. So A pin where it's connecting? N2 net. Y pin where it's connecting? Y pin is connecting to port P. Right? It is not O, it is like a bubble outside the unit. At last I have what? End module. So only this should be present in your gate level netlist. Means I have gates declared, right? 1, 2, 3 gates declared. But in the real design, you will be having lakhs of gates. So you can declare lakhs of gates like this. And gates and its connection. So connection is maintained, right? So you can see R gate output pin is connected to which net? N1 net. AND gate input pin connecting to which net? N1 net. Means what is the meaning? Output pin of R gate is connecting to N1 net. Input pin of AND gate is connecting to what? N1 net. The meaning is what? Output of R gate is connecting to what? Input of AND gate. Without this diagram, my tool can understand by seeing only this file. By only seeing gate level netlist, my tool can understand the connections. So here N2 net is connecting to output pin of what? AND gate. Same N2 net is connecting to input pin of what? Inverter. And the clearly indicates that output of AND gate is connecting to what? Input of inverter. Then the meaning is output of AND gate is connecting to what? Input of inverter. Means both are having connections. My tool can understand. So this is called as what? Gate level netlist. So in gate level netlist, you should be having only these gates declared and connections like this. Only this should be present in gate level netlist. No assign statement, no if statement, no case statements, nothing is allowed. Only should be having gate and its connections. That is called as what? Gate level netlist. So that is the difference between your RTL and gate level netlist. RTL is also Verilog program. Your gate level netlist is also Verilog program. But gate level netlist has gate and its connections. But RTL has design in the behavioral form. RTL can use any syntax. But gate level netlist should have only gate and its connections. No other syntax can be used. So after synthesis, now what we have done, design in the behavioral form, we have converted to what form? Gate level form. Role of physical design engineer is design in the gate form, convert to layout form. That is the role of physical design engineers. Right? So we'll see next. We'll take a break now. Now time is 11:20, 25. Right? We'll take a 15 minutes break or 10 minutes break. We'll take till 11:40. We'll continue again. We'll see what physical design engineers do and what is the syllabus content. I'll discuss. Then we can close the session. Right? We will take a break again. Now time is 11:25. 11:35. We'll come back again. Take 10 minutes break. So you have a restroom here. You can use it. Anyone want to use? So next we see after synthesis we have one more team called as what? DFT. DFT will do scan chain insertion. Then it comes to what? Physical design. That we will discuss in next steps. After break we'll discuss. Yes, we'll continue. Right. So after synthesis, right, whatever gate level netlist we get. So next is what? Physical design. So these are interest, right? Interest of our. So we also cover synthesis in our sessions. It's not only we're covering only synthesis, physical design. We also cover synthesis because sometimes you may also work on synthesis in the companies. Right? So in physical design, so first we'll discuss about the input files for for physical design, right? In our course. What are the input files required for physical design? So as soon as we start the course, we discuss something like basics of physical design, like what is transition, what is delay. Delay depends on what parameters. Like that. After that, we'll discuss about input files for physical design. So we have different input files like .lib, .left. Left has layout of all standard cells. We physical design engineers will not draw the layout. Layout is drawn from layout team. That is separate team, full custom design team. They will draw the layout and they will give the layout in the form of what? Dot left and dot GDS. We will discuss what the difference between dot left and dot GDS. So we will use dot left. So what is left? Library exchange format. So we use dot left. So what is dot TF? Dot TF is used in synopsis, but we use tech left. Dot tech left in cadence. Then what is TLU plus file? What is netlist? Netlist I've already explained now, right? Netlist, UPF, scanDef, MCMM file. So all these files we'll discuss first. So why we use, what it contains. We'll open the file and we'll discuss what is the content of each file. So after discussing input files for first 1 week, next we start discussing about. We start with partitioning. What is meaning of partitioning? See, when you have full chip, right? This is full chip. So we cannot do physical design on full chip directly because of huge runtime. Full chip has number of cells, number of standard cells, count is in crores. So we cannot do physical design. What we do, entire physical design, we divide into different blocks like this. This is block A. So full chip will be having core area and die area, right? So what we do, entire full chip, we divide into different blocks. This is block A. This is block B. This is block C. This is block D. Block E, F, G, H. Right. Entire full chip is divided into different blocks. So we engineers first work on block level physical design. We do physical design of each block first. Means each portion of Verilog code will be given. Right. It's like entire full chip is made up of this many blocks. Correct. So my RTL engineer will write Verilog program for each block. So you will be doing physical design for what? Each block. So entire physical design is divided into, entire chip is divided into some blocks. The shape of blocks may vary. So one block is in rectangle shape, one block is in square shape, one block is in what shape? L shape, one block is in inverted L shape. So that is called as partitioning. Partitioning this entire full chip into different blocks. So we engineers will do work on physical design of each blocks. Till 5 to 6 years, 7 years of experience, we will be working on block level design, block level physical design. So when you become experienced, right, what you do, you will integrate this block. Sometimes block can be divided into subsystems. So integration of block is called a subsystem sometimes, if block is very big. Integration of subsystem is called as what? Chip. If chip is small, integration of blocks are called as what? Chip. So till 5 to 6 years, we will be working on physical design of blocks. After 6 to 7 years of experience, you may work on full chip, integrating these blocks and doing full chip level physical design. So first step of physical design is divide this entire chip into different blocks. Right? It is called as what? Partitioning. Right? Divide chip into blocks. See, it's not always you will divide into blocks. What we do is we divide this full chip into first subsystems. This is one subsystem. Subsystem 1, this subsystem 2, subsystem 3, subsystem 4. So we may divide entire chip into different subsystems. And each subsystem may have different blocks. Each subsystem have what? Blocks. So integration of blocks may form what? Subsystem. Integration of subsystem may form entire chip. If chip is very big, we will first divide it into subsystems. Then each subsystem is divided into what? Blocks. So, or if the chip is very small, then we can directly divide blocks into what? Entire chip we can divide into blocks. So I have written here, we divide chip into what? Blocks. So we do block level physical design. So in block level physical design, so we have four major steps. Four major steps are floor planning, placement, CTS, and routing. Right? These are four major steps in physical design. So first we start with floor planning, block level floor planning. For example, you take any one block, right? This any one block you take. So that block we started doing physical design. So I will take one block. I assume the block is in square shape for simplicity instead of L shape. It is in square shape like this. So first we create this core area and die area. This block area we call it. Right? First we create this core area and we create this block area. I cannot create however I want. So the block level engineers will be told by whom? Full chip level engineer, how you want to create. For example, if block A engineer is creating core area and die area, how he has to create? He has to create his core area like this. This is the shape of the block, right? For A engineer. Because his block is in what shape? His block is in L shape,
Rectilinear.
rectilinear. You can call it as a rectilinear. So block level engineers are not deciding how to create core area and die area. Full chip level engineer will decide because he is going to fit your block in his area. Simplicity, I have used what? For simplicity, I have used square shape. But in general, you will be having different shapes. So in our design, in our project, we use rectilinear shape. We will not use square shape. We use rectilinear, means any one shape, U shape, L shape we use. So first step is creating core area and die area in floor planning, right? Creating core area and die area, or it's like your block area. The block level design is called as block area. In full chip level, it's called as what? Die area. So how to create this? What are different commands in Synopsys tools? There is your Fusion compiler. Synopsys, see, for physical design, I'll mention here what are the tools used. Better, right? Tools used is from Synopsys. We use Fusion compiler. From Cadence, we use Innovus. So what are the different commands to be used in Fusion compiler? First we discuss the project with Fusion compiler. Then we use, at the last 15 days, we use what? Innovus. So what are different commands? if we want to create covariant area, what are different parameters governing this, like utilization, aspect ratio, right? And how to create by using coordinates, what are different methods to create covariant area. And if the chip top is giving, the person who is handling full chip, right, he is called as what, chip top. If the chip top is giving covariant area, how he is going to give, in which file he is going to give, whether the def file or in a pickle file. So everything we discuss here, and we also implement that in lab, right? So next, after creating core area and die area for block level, next is what? Port placement. What are ports? Input and output of a block is called as what? Ports. So here, these are ports, right? In the RTL, whatever I have written, what are ports here? M and O. What is output port? Y. I have three input port, one output port for small design. But for bigger designs, I will be having plenty of ports. Hundreds of input ports, hundreds of output ports. So place those input and output ports physically by using piece of metal layers. Right? I use piece of metal layers. So place those ports. So you cannot place the ports wherever you want. These are just piece of metal layers. Right? This is M. What is this? This is M port. What is this? N. This O, P, Q. Different ports. So place the ports here in between core area and die area by using piece of metal layers. You cannot place the ports wherever you want. You have to follow the guidelines given from your chip top, because if all the inputs for block A, if you are getting from block D, then all the inputs you have to place here, right? All the input ports you have to place here. You have to place, even block A is also having core area and die area. So all the input ports you have to place here. If all the outputs of block A is going to block B, then all the output ports you have to place here. So all the outputs of block A, all the output ports of block A you place here. All the input ports of block A you place here. This has to be decided from full chip design only. If all the inputs for block A is coming from D, then I cannot place input ports here, right? Because from block D I'll get all the inputs here. So I have to place all the input ports at the bottom only. So where you have to place the ports in your block, the full chip level engineer will tell, according to his guidelines you have to place the ports. So you cannot, if your engineer is telling place the ports on the left, input ports you have to place on the left, all the output ports you place on the right, you have to place all the output ports on the right. Sometimes he only will place the ports and he will give the location. You can just source the file, it will place the ports. If you're telling all the input ports on the left, all the output ports on the right, then how to place it? So everything we discuss here in the port placement. Means how to place the ports, what are the commands, what layers we have to use, what metal layers we have to use to place the ports. So all the things we discuss in port placement. So after port placement, we have macro placement. What are macros? Macros are complex cells which are already optimized. Means the layout of macro is readily available. Then for this macros design, I will not write the Verilog code. I will not do synthesis because layout is readily available. Some macros maybe from some layout we directly reuse from full custom design team, means analog team. PLL, for PLL I cannot write the Verilog code. The PLL is designed from full custom design team. He will give the layout. I will directly reuse the layout. So macros are complex cells where layout can be readily used, like your polyogram mix, right? In home, polyogram mix you are not creating from scratch. You're directly purchasing from shop, MTR or GRB. Directly we are mixing with rice. because it's readily available. Why you will prepare from scratch? What is the advantage of using the polygram mix from shop?
Time
It's
saving.
saved. You will not waste the time in preparing from scratch. Any design which is readily available from the previous project, layout is available, you reuse that, right? And and second thing is, one is your time is saved. Second thing, why you readily use, why you use MTR polygraph powder or GRB, because that is the best one, right? Even if you prepare, you will not meet that expectation. If your mother feels that I can prepare better polygramics than them, then you can prepare from scratch. And if you feel that whatever readily available layout is not good, I can do it from scratch. Then write the Verilog code for that block also, and synthesize and implement those by using gates. And if you feel that that layout is already available in the previous project, then they reuse directly, right? Why you prepare from scratch? So two reasons. One is you are not sure that you may get the same results. Means the macros are already optimized. And second thing is you can save the time. So if you have any complex macros like that, first place it. Layout of macros you place it. Right? So I will place macros first. So we will discuss here. These are macros. So first we do macro placement at the beginning because macro count is less. These readily available layouts which we are reusing it, the count is less. Hardly the count varies from 10 to 100. Even there may be some blocks there is no macros at all. But standard cells, which is placed in the placement stage, the count is what? The count is in lakhs. So for that reason, first we do macro placement. So macros are the layout which is already available. I need SRAM in my design. I will not write SRAM RTL code. Directly I will instantiate SRAM in the netlist. We don't have SRAM gates. What are gates present in SRAM? We are not using in netlist. I only use SRAM abstract model in the netlist. So layout I will directly reuse. Yes, SRAM layout is already present in left file. This LEF file layout is already present. Directly I use the layout of SRAM. Directly means from the full custom design team, I will get PLL. I directly use PLL here. So there is no Verilog code what is present inside the PLL. There is no Verilog code what is present inside the SRAM. Directly we use layout of SRAM. For other circuits, we have netlist. Right? So these are macros. So how to place macros inside core area? What are the guidelines to be followed? Directly I cannot place. There are many guidelines describing macro placement. What are the guidelines? So we will discuss all those things in our physical design, right? Then after macros, we have physical cell placement. Physical cell placement means apart from the standard cells which is present in the netlist, we have some other cells to be placed, like tap cells, end cap cells. So what are the reasons for that? Like we have tap cells, end cap cell, tie cell, spare cell, decap cell. What are the reasons for placing these cells? Right? We discuss in our physical design course, and we place these cells also because without these cells, my chip cannot be fabricated. These cells are added because of design for manufacturability. See, these are physical only cells, means they have to be physically present, but logically they are not doing anything. They are not like AND gate or OR gate. They are doing some logical. They are doing some logical operation. No, they should be physically present so that my chip can be fabricated easily. So these cells are added because of DFM, means design for manufacturability. So after physical only cell placement, we have power planning. plan, we see every cell layout, right? When I place cells inside core area, so I am placing the cells in placement stage, but every cell which is placed inside core area requires what? Every layout requires VDD and VSS connections. So I have to plan how to give VDD and VSS connections for all the cells as well as for macros. That has to be gently planned. So planning of VDD and VSS is discussed in power planning, right? Power planning is done to give VDD and VSS connections to all cells and macros without IR drop. What is IR drop? What is IR drop? IR drop means, for example, you assume that I have one standard cell here. If not at placed, I have one standard cell here. This standard cell has this layout of standard cell. This standard cell has what? VDD. At bottom I have what? VSS. So there is some VDD present somewhere here. Port is present somewhere here, and my VDD is connecting like this. Connection happening with metal layers like this. So here VDD voltage is 1.5 volt. Like your textbooks, VDD will not be like 5 volts or 12 volts. At lower technologies, we use VDD in the range of 1.5, 0.75 or 0.95 volts. It will be in this range only. Here VDD is 1.5 volt, but the VDD 1.5 volt will not reach to my cell. 1.3 volt will reach to my cell. What happens to 0.2 volt? This metal layer has resistance, right? Whatever metal layer is used to connect from this port to cell, it has some resistance. And this metal layer is conducting. When the cell is switching, the metal layer will conduct current. So it is having some resistance, and this metal layer is conducting some current. That is going to result in what? Voltage drop. According to Ohm's law, R into I is going to result in what? Voltage drop. Out of 1.5 volt, zero point 0.2 volt is dropped on metal layer. Why? Because metal layer is having what? Resistance. If metal length is long, it has more resistance. If metal length is less, it is having what? Less resistance. Out of 1.5 volt, 0.2 volt is dropped on metal layer. It will convert into form of heat. And remaining 1.3 volt is reaching to what? Cell. Is there any problem? If less voltage is reaching to the cell, here VDD is 1.5, but 1.3 is reaching to the cell. Is there any problem? Yes, there is a problem because cell delay increases. If you have less VDD, cell delay what? Increases. If this VDD is going below some threshold voltage, it's affecting the operation of cell itself. If small voltage drop happen also, there is a effect because if VDD is going to drop, this is 1.5, instead of 1.5, 1.3 is reaching, means if 1.3 is reaching to the cell, instead of this 1.5, this drop is going to result in increase in cell delay. Cell delay increases. If cell delay increases, static timing analysis will go wrong. What static timing analysis I have done by using tool is going to vary with real world delay. Real world delay will be different because of IR drop. But what we have assumed, the cell is cutting to what voltage? 1.5. By considering this, we have done static timing analysis in the tool. So we feel that timing is good. But in real world, because of IR drop, the cell delay will change. Entire my assumption of STI will go wrong. So for that reason, this IR drop should not happen. If IR drop should not happen, what I should do? I should not have lengthy metal layers. So all those things we'll discuss. How to reduce IR drop. How to see that entire VDD is reaching to the cell. How to analyze IR drop. To reduce this IR drop, how to do power planning. Right? All those things we discuss in power planning steps of physical floor planning. So after power planning, next step is what? Placement. What is placement? Place All standard cells inside core area. All standard cells which is present in netlist, right? Inside core area. Means these are layout of cells, right? What are this? So in placement stage, I will place all the cells like this. So cell size will be small, right? Compared to your macro size. What is the size of cell? Cell size will be small, very small. I am writing little bit big, but it will be very small. 10 cells will make one height of macro. So, but I am writing a little bit big. These are all standard cells placed inside core area. So, we will discuss what are the different types of placement we have, right? So, in placement step, we will discuss different types of placement. How to control this placement? I can do timing driven placement, I can do condition driven placement. How to control the placement? What are the commands for that? Right? What are the steps in placement? Then checks after placement. What checks we do after placement? So checks after placement is, so we are going to check congestion. Congestion means whether my after placing the standard cells inside core area, whether this cells can be routable or not. Means whether it can be connected. Means connection not yet happened, right? Only we are placing. The cells has to be connected. This connection should be made. What is the connection here? Output of OR gate is connecting to what? Input of AND gate. This connection I have to make here. I have to make the connection through metal layer. That happens in routing stage. But the connection, whether I can connect all the cells. So for checking that there is a tracks available. For making connection, tracks are available to route the metal layers. Whether sufficient tracks are available or not. So all those checks we do, that is called as congestion. So we check congestion, we check max cap and max trans violation. Setup and hold violation. Setup violation, hold will check after CTS. So these major checks we do after placement. So we will discuss how to do these checks by using tool. Fusion compile, what are the commands? If there is a huge violation, then how to fix it? How to write a tickle automation program to fix this violation? Even that we discuss. Right. So after checks after placement, if checks are fine, if these values are fine, then we go for what? CTS. CTS means clock tree synthesis. So build a clock tree. See earlier, if you see this right, earlier one clock port will be connecting to all the flip flops. Like this. I will be having thousands of flip flops. Thousands of flip flops will be getting clock signal from what? One clock port. The load on the clock port is very high. So to reduce the clock load on the clock port, what we do is we build a clock tree like this. This is a clock tree. First, from the clock port, use what? One buffer. After that, right? After this buffer, use two buffers here. After these two buffers, again use what? Four buffers here. And this one buffer connect to what? These three flip flops. This one buffer you connect to what? These three flip flops. Again, this buffer is connecting to again these four flip flops. Again, this buffer will connect to these three flip flops. This buffer is connecting to what? These three flip flops. This buffer is connecting to these three flip flops. This buffer is connecting to these three flip flops. So this type of tree is called as H tree. Right? You can see the structure here. It is a H tree structure. So you can see the structure here, right? This blue color line. What is the structure? H. So you can see the structure here, H. So this clock port is not directly connecting to flip flops. First is connecting to what? This buffer. This buffer is connecting to what? This buffer and this buffer, and this buffer is connecting to these buffers, and each buffer is connecting to what? How many flip flops? Three flip flops. So build a clock tree like this. So why we have to build a clock tree? That we will discuss, right? In advanced part. What is a reason for building clock tree like this? What happens if I don't build clock tree? Right? Why clock tree? So what are the goals of clock tree? Like I have to meet latency and skew. So what is skew? What is latency? How to meet it? So after building clock tree, what are the checks after clock tree? Checks after building clock tree synthesis. These are the checks, right? Again. So checks after CTSS congestion, max cap, max trans violation. We also check what is skew. One second, I'll remove this. What is skew and latency, and we check here setup and hold. So these checks we do after CTS. So tool we have to do all these checks. If the checks are in the limit, right, every values are in the limit, then we are good to go with what routing. If all these values are not in limit, then we have to fix it by either using tickle program or one by one manually we have to fix, or we have to check. We have to redo the macro placement, right? If this is not good, again come up with macro placement. Again come from the beginning. So we have to do. You have to implement different methods to fix these values. So how to fix this? We'll discuss. Then routing. What is routing? Correct all the standard cells and macros by using what? Metal layers. Standard cells, macros, everything you connect through what? Even ports, right? So everything you connect through metal layers according to the connections mentioned in the netlist, right? These connections. So here output of OR gate is connecting to what? Input of AND gate. According to connections mentioned in the netlist, connect all the cells, macros and ports by using what? Metal layers. That is called as routing. Connect all cells, macros and ports using metal layers. So after this again we'll check what is DRC and what is LVS. What is DRC stands for? Design rule check. See in the foundry we will get some rules. So between one metal layer to another metal layer, you should be having some spacing, right? Minimum spacing you should have maintained. This minimum spacing you should have maintained. So you should have maintained minimum width, and via rules will be there. So all the rules are maintained here or not while doing routing. You have to check. So those rules are present in TF file. At the beginning, I told we get different files, right? Those rules are present in which file? TF file, technology file. So whether those rules are maintained or not, we have to verify. That is called as what? DRC. What is LVS? Layout versus schematic. What is layout? This is layout, right? So these are layout of standard cells. What we are drawn here, it's not simple blocks. What are this? All these are layout of standard cells. So what is LVS? Layout versus schematic. This is layout. What is schematic? Your netlist is schematic. Your outer netlist is schematic. So in this schematic or in the netlist, output of OR gate is connecting to what? Input of AND gate. Whether same connection is maintained here or not. The tool will check. Here output of AND gate is connecting to what? Input of what? Inverter. So whether same connection is maintained here or not. My tool will check. If any unnecessary connection is happening, that is called as what? Shorts. If any connection is not happened, that is called as what? Open. My tool will check that. That is what called as layout versus schematic. Means all the connections in the netlist, whatever mentioned, the same connections is present in the layout or not. Checking that is called as what? Layout versus schematic. After that, we'll do all these checks again. Max cap, max trans. We will do it. So after all these checks, after routing, we do sign off checks. Sign off checks. Sign off checks are first is IR drop and electro migration check. I explained you right. IR drop. What is IR drop? Whatever whether the proper VDD is reaching to cell or not. So some part of VDD may be lost in what? It may be lost in metal layers. So we do IR drop and electron migration check. To do this check, we are not going to use Innovus or FC shell. It is done in separate tool called as Redoc or say separate tool called as Voltus. So these checks we do. Next is timing sign off. Means what setup and hold we are doing, right? Each stage we are doing setup and hold. We can do it in Innovus or FC shell, that is used for physical design, but that is not accurate. So instead of that, what we do it in accurate tool, right? Timing sign off we do by using what? Prime time. Prime time in synopsis and tempers in cadence. We do timing sign off. Means right, timing sign off means these checks: max cap, max trans, setup, hold, pulse width violation. Some checks is there. All this setup and hold, max cap, max trans. Anyhow, we have done after routing stage in FC shell or in Innovus. But still, we do using these tools because these tools are not accurate. This is very accurate. So we do it in timing sign off tool. RC extraction we do it in star RC. Next third tool is physical verification. So in physical verification we will do DRC, LBS, ERC, the same thing what we did out of routing ratio, right? We'll do here. So here we use IC validator or PGUS or PVS from this one. But industry uses caliber, right? Industry, but that is a mental graphics. We don't have that tool. But physical verification, we have physical from Synopsys. We have IC validator, and from Cadence we have PGUS. I think RSP instead of PGUS, right? We have PVS, physical verification system. I don't know, but now only we have got the tool. I have to check it. Cadence earlier we don't had. Now from this batch we are using Cadence also. So after doing all these checks, your block is ready. After your block is ready, your full chip level designer what he will do? He will integrate the block After integrating all the blocks, after that what we will do, we will take the GDS. That GDS will send to foundry for fabrication. So these are the steps. So here, these are the steps. But to understand what is setup violation, what is hold violation, right? So there is a concept called as STA. So we do that STA after floor planning. STA stands for what? Static timing analysis. So what here we discuss what is delay and transition, on what parameters depend upon. Next we discuss on what is latency, skew, uncertainty, different types of clocks, setup and hold violation, max cap, max trans violation, false path, multi-cycle path, asynchronous paths. So all these things we discuss in STA, that is using each and every step. This is our course content. From synthesis we do it. So till this point. So if you have any doubts, I completed from I completed my explanation. You can ask me if you have any doubts. See, physical verification is covered, right? But whatever why we are see we are not specifically using IC validator and doing it because we are not getting any violations. What violations we are fixing here only. When we are moving to physical verification tool, right? We are not getting any violations with whatever design we have. So we are not specifically showing it. So if you have violations, so if we in the new see we are getting new design from Cadence. In that design, if you are getting violation, then we can also show that. So just it is a verification, right? Whether you're getting violations or not. If you're getting violations, then specifically if you're getting N tap violation, then you should fix. We should place this N well means tap cells properly. Like some suggestion should be given. So if violations are there, we can show that also. Physical verification. See, only this we will not do. Right? IR drop and electron migration will not do it in tool because we don't have Redux tool with us. Theory will be done. This hands-on we are not doing it. Redux or Voltus because that is separate license. It is very huge value. We are not doing it. Hands-on we are not doing it, but theory part we are covering it. But other things we do hands-on. I am telling it at the beginning only. This we do hands-on, right? RC extraction we do hands-on. Prime time we do hands-on. This physical verification also we can do hands-on because same thing we are teaching here only how to fix DRC and LVS, how to redraw it. We are doing it, but still, if you want us to show, I will show how to invoke IC validator, how to check the issues, how to means how, fixing here is of no use. You have to fix in again back in. See, even though timing sign off I am doing here, fixing here is of no use. Again, I have to fix back in what my inverse and prime time because that tool only can write the GDS. Here, this tool cannot write the GDS. Here only we can identify what are the issues, what are the methods to fix. We can mention to the physical design team, they will fix it. So even in company also these teams are separate. So they will take your block, they will see what are the issues, they will tell how to fix it. They'll give ECUs, you have to fix by using ECUs. So this we are not, STA is covered. See, STA is done every step, hands on it is, right? After placement, we do STA. After CTS, we do STA, hands on. After routing, we do STA, hands on. Timing sign off, physical verification is done hands on. Only this is not done hands on. So every step requires STA, that is done hands on. Even prime time tempers, we do hands on. We'll show it on hands on how to use prime time, how to load the design in prime time, everything will show it. Is any other doubts from on offline? So online students, please hold on. I'll talk to offline guys. Any doubts you have? It's verification. I told you right. We are doing it. See, there are few companies. They ask us to do these things by you also. Means some lead will guide you, right? You should drive it. But these separate leads will be there. They will guide you. In some companies, and what they will do, the teams only are different. You will do only physical design. They will do this verification, timing sign up, physical verification. They will guide you what changes. See, changes implementing here is of no use. These changes, whatever fix they are mentioning, that has to be implemented again back in what? Innovas or FCCL. So they will tell you have to do it. So the same thing we are doing here. We will load this tool. We will see timing issues. We will fix timing issues here. Fixing here is of no use. Whatever issues we are fixing here, we have to bring back to our implementation tool. Implementation tool means it is Innovas or FCCL. We have to implement those changes there. That is called as ECO, Engineering Change Order. The ECO implementation is done. So we are doing this. I told you, right? We are doing these two things. So this is our course content. So this is why physical design. What we do in physical design I have mentioned. And what is our course content I have mentioned. So PD course content is same, whatever I mentioned above. So at last, any queries from offline, other queries? Okay, if you're done, you can go. Online, any queries? Again. So when course starts, everything will be informed from by our office staff. They'll inform you everything. In WhatsApp, if you have enrolled, right, or if you have texted them, they will inform you back when course starts. Everything they'll inform you. Timings and all they'll inform you. Apart from that, the course when the basic starts. If you have any other doubts, you can ask me. Huh? Two it is already given. Then what's your doubt? You want to attend on weekends? Okay, see, I think okay, how to use in skills, right? I think they'll inform you how to use. Someone admin will join. He'll schedule a meeting, and they will inform you. So there is nothing in skills. You have username and password. Enter that whatever courses you have enrolled, right? For example, basics. You will see the physical design theme or something. If you click that, you can see the videos. Live session videos will be there, or pre-recorded video will be there. Means from the best trainer, pre-recorded video will be there. That is one video. One is live session videos. Live session means today if session is completed, that video will be added after 3 hours. Because for us to upload on the server, right, we require 3 hours because it's 3 hours video. After at 12:30, if the session is done, at 3:30 or 4 o'clock, you can get the video. Or you'll get in the evening. If the session is done in the evening, then you will get in the next day morning. Because some session will complete at 5 o'clock or 5:30, right? That session will get in the next day morning. Because 5 6 o'clock our staff will leave. You will get in next day morning. So you will get the recorded videos. That is why we use InSkill. So admin will teach you how to use it. Or in the first session they will teach you how to use it. first session, the mentor who is doing, right, he will tell you how to use it.
Sir, recorded sessions, it's available only 15 days only, no, sir?
Yes, live recorded sessions are available only for next 15 days. There will be pre-recorded videos. For example, if you take digital, right, by the best trainer, pre-recorded videos are there. That is available for entire course content. Pre-recorded videos, live recorded sessions, because we have many classes going on. We cannot maintain all the sessions in the server. If we upload today, it's available for next 15 days. Only live recorded videos. Previously recorded videos by best trainer, that is available for entire course content. So this session, you are enrolled for this session. This session recorded video will be available for only next 15 days. Today video will be available for next 15 days. Tomorrow video will be available for that next 15 days.
Okay, sir.
27th video will be available for next 15 days. From 27th to next 15. It's available on your InSkill portal. After next 15 days, it will be refreshed.
Sir, we are placing after the job this in-skill login is blocked or not, sir?
See, that is InSkill recorded videos, the same thing. When the tool access is removed, InSkill access is also removed. But it's not a hard and fast tool that we should remove it. On the request from the admin, they will increase your visibility time. Right? Everything they will increase. Uh, that you can talk to the admin. He may increase after year.
Okay, sir.
If you want to use for next 1 month, you can increase it. But you have to come up with a genuine
Okay, sir.
reason, because what the students are doing is they are giving their in-skill username and password to their friends who are not all enrolled for the.
Okay,
Then what
okay.
is the difference between the person who is enrolled and who is not enrolled? That person is using the tool. For that purpose, we have all the security measures implemented. If you
Okay.
genuinely have issues, if you not watch the videos, then you can request the admin. He will extend it.
Okay, sir. Thank you.
That we have done many times for the students. The student who was enrolled, and there is no restriction that you should come. If for any reasons, if you're discontinuing the batch, you can join the next batch without any fees. We're not going to charge any fees for that. Once you enrolled, don't discontinue. By chance, if you're discontinuing for any reasons like health issue something, you can rejoin to the next batch. Only with proper reasons we can do that. The ultimate thing is students should get benefit of the content what we are teaching, and students should get the job. Then only we will also get the good reputation and what good reviews. Right? That is what our ultimate intention. Whatever support we should make, we have to make, we can make, we will do it. Our institute will do it. We means it's institute for proper learning purpose. So by defaulting the amount, like giving your username and password to some other candidates who are not at all enrolled, or selling it, it's like not good. For that reason, we have taken some measures. That's it. See, physical design, hard, fast rule, it is 6 months. There is nothing to do after 6 months. It's you have to do after 6 months. You have to work on one more project. We can guide you on one. The flow remains same. Any project you take from floor plan to routing, the flow remains same. You take one more netlist, you start working. So we going to start compulsory. We will stop at 6 months. We will never continue after 6 months. I told you right. There may be a margin of 1 week extra or 2 weeks max to max. See, if that is because of holidays. See, Diwali came in between. There was a 3 day holiday. If that is the case, it may extend. If there is no holidays, it will not extend. Hmm? Communication. How? So there was a option. We had we have the English mentor here. in the institute for communication. I don't know what is the status now. You please ask the admin. But before going, you please check with him. I'm not sure. I think it is continued because I am going to only take on weekend. I'm not going to take on regular days. I'm not sure. I'll ask the admin. One second. I'll give me time. Yes, the English session is also there. Communication. If I take PD, okay. See, in portal, pre-recorded videos and live recorded videos both will be there. Pre-recorded videos is for your reference from our best trainer, what they feel. Right? Live recorded is easier from the present trainer who is doing it. Real-time project. See, we do two projects in this entire flow. One project will be done with the help of mentor. Another project will give to you people you can do it. Right? So two projects will be done. So students will not do second project. If you are coming with the interest of doing second project, we will give you the second project also. So resume building, it's like if I do complete one session for resume building, right? Every student will do same resume. So admin will forward the resumes, previous resumes, sample resumes. He will forward. So you can take that as a guidance and you can build your own resumes. Or if you want support for resume building, you can talk to the admin. He will guide you. In the regular sessions only, they can do the resume building also. See, resume building is not a big thing. Like you can mention the same project. Everyone is mentioning same project, but don't do same words. That's it. Same project everyone should mention. If you are a fresher, if you are experienced candidate, there is. If you want to claim experience, then there is separate resume building session. That recently also I have done for some experienced candidates. That you contact admin. Admin will guide you what you have to do. Or experience resume building sessions, right? You can contact admin. Admin will give you either a pre-recorded video for resume building or he will assign some mentor to guide you. Mentor is up. See, 6 o'clock means mentor will be having sessions. Apart from your session, other sessions will be there. She will be available for your batch. After your batch, you can extend. See, currently also when I do session now, my session completes at 12:30. I will be clarifying the students until 1:30. After sessions, you can discuss with your mentors. Or during session only you can discuss. Means in the lab session, right? You will there is not like theory continuously you have to discuss. It's for example, if others are not done, if you're done early, you can discuss with your mentor. So mentor is available in the institute from 9 to 6. Mentor is available. We have both mentors. One is Shakila, one is Chetan. We have two mentors. Both are available in the institute from 9 to 6, but they are also engaged with other sessions. Even at their free time, you can meet them. Or in your batch, after the session completes, you can ask your queries. Okay, if you are done, you can go. Or if you have any doubts, you can ask me. So career gap is good for VLSI. If you have career gap, it is good for VLSI. Right? So pass out students is immediate passed out and career gap. If you talk right, career gap is good. So the service-based companies, they will put the experience on this career gap and they will take you. So that is good. So don't publish this everywhere. That is the truth. So the career gap is not an issue. See, but don't have career gap more than 10 years. If you are having before 2014, right, then your salary matching is very difficult. So 3 to 4 years, 5 years of career gap is fine. Even six is also fine, but more than 10 is not good. Okay, thank you everyone.
Thank you, sir.